Welcome back. Today we're going to be exploring 3.4 exponential decay. Last class we talked about exponential growth, like as in a bank account that just keeps compounding more and more and more money. But the same way that exponential growth can build money, exponential decay can destroy the value of assets. For example, the classic, a new car. Malik bought a new car for $15,000. Muzzle tov. As he drove it off the lot, his best friend Will told him that the car's value just dropped by 15%. True fact. And it would continue to depreciate or decrease by 15% of its current value each year. If the car's value now is $12,750 according to Will, what will its value be after 5 years? Complete the table below to determine the car's value for each of the next 5 years. Round each value to the nearest cent. Now, you'll notice we have right here a table where the first column has been the number of years, the car's value after T years. So as soon as you drive the car off the lot, you lose 15%. So that's 15% of 15,000 right here. And then over the course of the next year, it'll lose another 15%, meaning at the end of the first year, it'll be 12,750 minus 1,912 for a total of $10,837.50. Now, since this is a table problem, it is very helpful for our classic spreadsheet. And let's unpack what's going on here. So we can set this is equal to 15,000 times the whole 1 minus 15% or 0.15. That gives us the same value. Then we can say, okay, give me 15% of whatever's in column B4. That gives us our $1,900 approximately, followed by, please give me the value of the difference of the value at the beginning of the year minus 15% depreciation for a total of 10,837. We can then take that to the next line equal to whatever the data is in D4, either by clicking or typing D4, and then use our handy dandy tool of just pulling everything down. And notice as we do that, let's get rid of that, that's bad data. As we do that, it calculates how much will be the value of the car at the end of every year. So if we want to know at the end of 5 years, the value of the car will actually go down to $4,808 plus change, which is incredible. That is less than a third of the value of the car as it came off the lot. So we can now update our data over here, and that's our complete data. This type of mathematics is so important that people don't just want to create spreadsheets, they want to create an actual model to write what's the relationship. And just as we had recursive models for sequences and explicit equations for sequences, we have ones for these too. The recursive model says something like this, where whatever my principal is this year, so let's put in the equation there, my principal or principal this year, it was equal to 1 plus R, where R is the interest rate or depreciation rate, depending on what's going on, of P minus N minus 1, which is the principal the year before. Last year's principal. Now, it doesn't have to be principal. Let's correct the spelling on that. It doesn't have to be last year's principal. It could be last month's or whatever. In the next video, I'm going to explain how to use these two models to answer the questions in order to make predictions. Follow up with me there. See you on the other side.